Hello, Mr. Geiselhardt here, and we're going to go over homework number 2, graphing the exponentials. So first let's take a look at the general equation for an exponential. We have something like y equals plus or minus a times b to the x minus h plus k. And this may seem pretty daunting and a lot of things that you're thinking of at once, but each one of these things does a very specific thing to the graph that we'll be able to figure out. So let's just talk about this in order. The first thing we're going to take a look at is this plus or minus here. Now, the plus or minus determines whether the graph goes to infinity or goes to negative infinity. So just to give you a real quick sketch of what that looks like, if we have our axis that looks like this, the graph of an exponential that's positive will go up like this, or it'll go up like this. So it goes to positive infinity. If it's negative, it'll either go down like this, or it'll go down like this. So it determines whether it goes to positive infinity or negative infinity. The stretch factor A. Now, we're not going to worry about the stretch factor A in this unit. All we're going to do is for A, it will always equal 1, so it's really not going to be there. The stretch factor would do exactly that. It just stretches the graph out, makes it go up faster or slower depending on what that is. But again, it's just going to be 1 for all of our values. The b is the base. That's the number. This is the number that is being raised to the power of x, or x plus something, or x minus something. Now, when we get to the graphs, and this will make more sense here in a couple minutes, it says determine the distance from the asymptote 1 unit to the left or right from the locator point. Now, that might not seem to make a whole lot of sense right now, but once we start graphing, that'll make a lot of sense. This h moves the locator point to the left or the right. Now, if this is a minus, it moves it to the right. If this were a plus, it would move it to the left. And then the k. The k moves the asymptote either up or down. If it's positive, it moves the asymptote up. If it's negative, it moves it down. So now we'll go ahead and take a look at a couple of examples so this will make a little more sense. Okay, here we're going to start with a very straightforward example. We're going to start with the example of y equals 2 to the x, probably the most simple exponential equation that you can have. Now, notice that there's no h or k value. When there's no h or k value, the locator point is going to be 1 unit above the asymptote. In this case, the asymptote is just at the line y equals 0. Okay, so since there is no k, we start with the asymptote at y equals 0, which is the same thing as the x-axis. The locator point is 1 unit above that, and the reason why that is if you were to take the point 0, 1, and you put it into the equation, you would get 1 equals 2 to the 0 power, which is true because remember, anything to the 0 power is equal to 1. Now, to find the second point, that's where we talk about the distance from the asymptote. So you're going to go 1 unit to the right or 1 unit to the left. Now, whether you go to the right or left is determined by if b is a fraction or if it's a whole number. If b is a whole number like 2, 3, 4, 5, 6, you're going to go to the right. If it's a fraction like 1/2, 1/3, 1/4, you would go to the left. Then the distance between the asymptote and the next point you're going to put is whatever the b value is. So in this case, b was 2, so that means I would go up 2 units from the asymptote to get to that second point. So it's also positive, which means it goes to infinity. That's why it's going up like this. So the points we have to be aware of, or the points we have to really look for, is 1, where's the asymptote? That's probably going to be the first thing you're going to graph. This value k is what tells it that. If k is 0, then it's at y equals 0. If k were 1, it would be y equals 1, and so on. Then you're going to go to find the locator point. The locator point is just 1 unit above the asymptote, and it's always going to be there. It's always going to be just 1 unit above the asymptote. Okay, and then to find the second place, you either go to the right or to the left, and then whatever this number is, that's how many units you go up. Okay, let's take a look at this example. Now this is an example, again, we're using just y equals 2 to the x, but I also graphed y equals 2 to the negative x. Notice it's just a reflection, it's just a mirror. So everything we did in the last problem still applies here, except we just go down instead of up. So when we start at our locator point, here we would go up 1 to the point 0, 0, 1. If it's negative, we would just go down 1. So that would be 0, negative 1. The second point, again, since it's 2, it's because the asymptote, I probably should have drawn that in, is right here. It's 2 units up here. And if you have a negative, it would be 2 units down here. So that's negative 2. So a negative 1 is really just a reflection of the positive 1. Okay, now let's see what happens if we change that h and k. So I left the original graph on there just so you can kind of see how everything moves from where we originally were. So like I said before, you're probably going to want to start off by putting in the asymptote. Because this value here, my k value is a positive 2, that means I move my asymptote up 2 units, which is what we did here. So instead of being at y equals 0, it's at y equals 2. Now, to find the locator point, it's 1 unit above. But see where this says negative 3? That means I have to move my locator point 3 units to the right. Here's what I mean by that. My original locator point was right here. That's the point 0, 1. Now, I have to move it 3 units. So 1, 2, 3 units to the right. And then since the asymptote is here, I have to go 1 unit above the asymptote. So that's my new locator point, and that will be at 3, 3, 3. Now, another way of looking at that is notice that from the original locator point, it's over 3 and up 2. So that's 3 to the right and up 2. That's another way of locating the new point. However, you won't always have the original graph there, so you might not always see where that locator point is. So notice that when we find the locator point, it's 1 unit above the asymptote. So if I were to just follow 1 unit above the asymptote, all I have to do is look and see where does the graph cross the line that's 1 unit above. And it only happens in one place, so I can also find the point that way. Now, since this is a number that's a whole number, like 2, that means I go 1 unit to the right, and then I'm going up 2 units from the asymptote because that's a 2 there. Okay, here's another example, and I want to go ahead and point out a couple things. The first thing I want to do is draw on my asymptote. Notice that that's at negative 1. So I go down 1 and I draw my asymptote there. The next thing I want to do is I see that this is a plus 3. That means that my locator point is moved 3 to the left. So if it starts off here, it moves 3 to the left. Now because it's negative, that means instead of going up 1, I have to go down 1 unit to find that locator point. So my locator point is right here, and that's going to be the point negative 3, negative 2. For my locator point. And then to find the other point. Now, again, because this is a whole number here, I go to the right 1 unit. So here's my locator point, go to the right 1 unit, and now I have to go 4 units in between the asymptote and where my next point is going to be. And that's a 4 because it's a 4 there. And again, because it's negative, we go down instead of up. Once you have the 2 points, then you have the sketch of the graph. It just goes through those points and it tails off at your asymptote. Okay, now let's take a look at a graph that has a b value that is a fraction, in this case 1/3. So let's just go through the whole process again. First thing I'm going to want to do is find my asymptote. That's at negative 3, so I go down 3 units and draw on my asymptote. That's right here. The next thing I want to do is find my locator point. Well, it's 2 units to the left, or it's just 1 unit above the asymptote, and it's 2 units to the left. So that's going to be my locator point right there. The coordinates of my locator point in this case will be negative 2, negative 2. Now, here's where it's a little different. What I'm going to do now is instead of moving to the right 1 unit, I have to move to the left 1 unit because this is a fraction, not a whole number. So I'm moving to the left. Whatever's on bottom, whatever this number is here, you're only going to have fractions of like 1/2, 1/3, 1/4, 1/5. There won't be any number on top except for a 1. So this 3 is how far I have to go. So I go up 3 units. Just like we would if it was on the right side in a 3, 1/3, we go to the left and we go up 3 units. So that's my second point. Once you have the 2 points, you can go ahead and draw that in and sketch it in there. Okay, now we're going to go ahead and I'm going to do a graph kind of from scratch without having it already on there so you can see what we're doing. So the first thing I'm going to want to do is go ahead and find my asymptote. In this case, since it's +1 for k, that means my asymptote is at a +1. So I'm just going to draw that in here. So it's going to look something like that. The next thing I want to do is find my locator point. Okay, so my locator point is 1 unit above the asymptote. In this case here, I need to go 2 units to the right. Now, when I say 2 units to the right, it's from when x equals 0. So we go over 1, 2 units. Whoops, I made a mistake there. I should only be 1 unit above the asymptote and over 2. So this is my locator point right here. Since this number here is a whole number and positive, then that means that I'm going to move 1 unit to the right. So I move 1 unit to the right, and because this number here is a 3, I have to go 3 units from my asymptote. So 1, 2, 3 units from my asymptote is right there. So I have my 2 points, and I have my asymptote. So now I can go ahead and sketch this function. It's going to look something like that. Okay, here's another example. Let's go ahead and do the same thing with this one. So again, I'm going to start with my asymptote. That's at -2 because k is -2. So I'm going to put that in there. The next thing I'm going to notice is that this is negative. So instead of going up, I'm going to go down 1 unit from the asymptote to find my locator point. Also, this is +1, which means I move 1 to the left. So 1 to the left and 1 unit below my asymptote would put me right there. Because this is a fraction, instead of moving to the right 1 unit, I need to move to the left 1 unit. And since it's 1/4, I need to go 1, 2, 3, 4 units away from the asymptote. So I have my asymptote and I have my 2 locator points. So it will look something like that for my graph. Okay, now we're going to start by giving you the graph and see if we can come up with the equation. So I'm just going to start off with y equals. Now, the first thing I'm going to do is I want to find my k value. Remember, k is how far the asymptote moves up or down. In this case, my asymptote would be right here, so k would equal a -3. The next thing I need to do is find my locator point. My locator point is right here. Now I know that's my locator point because that's the spot 1 unit above the asymptote where it crosses the graph. Notice I moved 1 unit to the left, so that means my h value will be +1. Because remember, if it's positive, it moves to the left. If my h is negative, it moves to the right. So then what I'm going to need to do is find my next point. Well, I have to look at where the graph crosses 1 unit away. So if I go over 1 unit to the right, I see how far up from the asymptote we go. So that would be 1, 2, 3, 4, 5 units. That means that my b value is equal to 5. Now, we always said that a is 1, so we're not going to worry about that. And since it goes up to infinity instead of down to -infinity, I know that it is a positive, our positive equation. So my final answer is going to be y equals 5 raised to the x plus 1 power minus 3. And that's going to be my equation. Okay, here's another one. So the first thing I'm going to do is try and find my k value. Well, in this case, I moved up 1, 2, 3 units to get my asymptote, which is right there. so that would be 3. Now, let's find where my h value is. Well, I'm moving to get to here because that's where it crosses 1 unit away. That's 2 to the left. So that would be plus 2 for my h. Notice that it goes down to negative infinity. That means that whatever my b value is, it's going to be a negative number. And then I just need to see how far away from the asymptote it is. In this case, it's 3 units, so that would be a negative 3. So when I write my equation, I would have y equals negative 3 to the x plus 2, and then plus 3 for k. Now, there's something I should note here. When you're doing this equation, it should be y equals negative 3 to the x plus 2 plus 3. It should not be negative 3 in parentheses. Your parentheses should not go in there. The parentheses don't belong. So make sure you write it like this, not like that. Okay, one last one when we're looking at the graph. So again, let's start with my k value. Where's that at? Well, here's my asymptote, and that's 2 units down, so k is equal to negative 2. I find my locator point is right there. That's 1 unit above the asymptote. And that is going to be h. Now, since I'm going 1 to the right, is equal to a negative 1. Notice that it is, since it's going up to the left, it's going up over here. That means I'm going to have a fraction for my b value. So I have to go over 1 unit and up 1. That's going to be my next point. Notice that is 2 units away from the asymptote, so that means my b is going to be 1/2. And again, it goes up to positive infinity over here, so that means that it is positive. So my equation will be y equals 1/2 to the x minus 1 minus 2 will be my equation. And now I'm going to show you how you graph the assignment. If you're given an equation and you want to graph it, a couple of things. First of all, you have to make sure you choose the right one. Now, some of the assignments or some of the questions will give you an option here. Some of them will just show you or tell you which one to do. You're going to use this one. Notice it has a horizontal asymptote and 2 points. This is the one you're going to use whenever you're doing an exponential. Okay, so once you do that, the first thing that you need to do is you need to, let me start this over here. The first thing you need to do is you need to pick that graph, and then you need to go to where your asymptote is. Once you have your asymptote, you're going to click anywhere on that asymptote, and it'll draw it in. Now, we got that because we know that it's at negative 1. Next thing we need to do is find our locator point. The locator point in this case is going to be 1 to the left. Again, it's 1 unit above my asymptote and 1 unit to the left of 0. The next thing we need to do is find the second point, and we're going to check our answer here. So to find the second point, which we found right here, that's just the 3. That means it's 3 units above that asymptote. So kind of just to go through this once again, first thing you're going to do is click anywhere on the line where there's the asymptote. It doesn't matter where, left or right. It just has to be the right height. Then you go and find your locator point. In this case, it was 1 unit left. So you go above your asymptote 1 unit and then 1 unit to the left. And that's going to be your locator point. To find the second point, you're going to go to the right because this is a whole number, not a fraction. And you would go up 1, 2, 3 points, click your second point, and then it will automatically draw that graph in there for you.